Hello students, today we are going to study about chromatic aberration in a lens. In optics and spectroscopy, the focal length of lens is 1 by f equal to n minus 1 into 1 by r1 minus 1 by r2. Here f is the focal length. The f is give differences for the different wavelength of colors. This process is responsible for chromatic aberration. These chromatic aberration are characterized as two types. They are longitudinal chromatic and lateral chromatic aberration. We see about what is longitudinal chromatic aberration. A single beam of parallel light is entered into the convex lens. Here we use the converging lens for the dispersion. The convex lens is parallel for the principal axis. The dispersion is finally done by the prismatic action of the lens. There are two types of colors are dispersed here, that is real and red and violet rays. The red rays are leastly deviated and violet rays are most. Red rays are used for focusing the point further, but violet rays are not because it is most deviated rays. So focal length of red is greater than the focal length of violet rays. By the differences Fr minus Fv, we can see in the slide. This differences equation is used for measure the axial chromatic aberration of a lens for the single beam of rays. Then we see the expression for longitudinal chromatic aberration. 1 by f equal to n minus 1 into 1 by r1 minus 1 by r2. Here Fv and Fr and Fy be the focal length of violet, yellow and red colors. We already know that n is a refractive indices. That also applied for this equation as a Nv, Nr and Ny. Three colors also included for these refractive indices. So we can write the three equations for these three colors by using the focal length equation. So 1 by Fv equal to Nv minus 1 into 1 by R1 minus 1 by R2. This is the first equation. 1 by Fr equal to Nr minus 1 into 1 by R1 minus 1 by R2 is second equation. And finally 1 by Fy equal to Ny minus 1 into 1 by R1 minus 1 by R2 is third equation. Subtracting from second equation to first equation. So 1 by Fv minus 1 by Fr equal to Nv minus Nr into 1 by R1 minus 1 by R2. Here 1 by R1 minus 1 by R2 is a common for both the equation. Then from the above equation, cross multiple between Fv and Fr and divide and multiple the Ny minus 1. From this all process, we get the final answer. Fr minus Fv equal to omega into Fv. Omega is the dispersive power. Then discuss about the lateral chromatic aberration. Here also we use convex lens and we use the object that is pointed as A and B is placed before the lens. Here also we measure red and violet rays, but the other colors are found between the two. Here changes are held that the size is red image is greater than the violet image. So we can written as BRAR greater than BRAV. By the differences, BRAR minus BVAV is measured for lateral or transverse chromatic aberration. Transverse means horizontal mode. Then you can see the diagram for both the topic in this video. 2 points for eliminated the chromatic aberration is keeping the two lenses in contact with each other and keeping the two lenses out of contact. Thank you for watching.
In this video, we are going to learn about direct vision spectroscope. The direct vision spectroscope consists of the 3 ground and 2 flint glass prism of suitable refracting angle. The prism are fixed in the metal tube A. Collimating lens fixed one end, then another end tube of the telescope. The angle of prism such that the total deviation produced by the mean ray is 0. The refracting angles of crown and flint glass prism in opposite direction. Thus the deviation produced by the crown glass prism one direction equal opposite to that produced by flint glass prism in opposite direction. There will be resultant dispersion and the dispersed beam is almost the parallel to the incident beam. The prism are the cemented together with Canada blossom. Mu is equal to 1.54 to the minimize the reflection losses at the interference. The spectroscope of this type is very handy, is used to the steady quality. Then spectra are different source of light. Use of more than prism increase the resolving power of instrument. The spectral lines will appear separated from one another. Then diagram. Optic axis longest, central wavelength, shortest in two prisms. So entire slit, lens PGP component, spectral slits, then matrix detector. Thank you.
Welcome to everyone. I am Brinda, Basic Physics second year in Dr. Umayama College for Women. Today's chapter for optics and spectroscopic. Going on topic for Michelson interference meter. Principle of Michelson interferometer are the two interfering beams are formed by division of amplitude. The amplitude of the beam from an external source is divided into two parts of equal intensity by partial reflection and refraction. These beams are centered in the two beams are finally brought together after reflection from the plane mirrors to produce the interference fringes. Types of Michelson interferometer M1 and M2 are front silvered plane mirrors. The two mirrors are founded vertical on two arms at right angle to each other. The planes of the mirrors can be straightly filled with the fine screw at their backs. The mirrors 2 is fixed. The mirror 1 can be removed parallel to itself by means of a very sensitive micrometer screw. G1 and G2 are two plain parallel glass plates of equal thickness. The plate G1 is semi-silvered on the back side. G1 is a beam slipped such that beam incident on G1 is partially reflected and partially transmitted. G1 is incident at an angle of 45 degrees to incident beam. G2 is called the compensation plate. S is the light source in zone the figure of Michelson interference. Light from the source S is rendered parallel by a lens L and falls on the glass plate G1 at an angle of 45 degrees. At the back surface of G1, it is partly reflected along a AC and partly transmitted along a B. Reflected beam move towards the mirror 1 and fall normally on it. It is reflected back along the same path and emerges out along AT. The transmitted ray AB falls normally on the mirror M2. It is reflected along the same path. After reflection at the back surface of G1, it moves along the AT. The two emergent beams have been derived from a single incident beam and are therefore concurrent. The two beams produce the interference under the suitable conditions. Thank you all. Thank you for watching.
Morning to all. I am talk about protection and detection of plane, circular and elliptical polarized light. Protection of plane polarized light. General a nickel prism is used producing plane polarized light. Beam of unpolarized monochromatic light is passing through nickel prism. It is split up into O and E components inside the nickel. O components is totally referenced at the canadablastum layer. Observe the black insides. E components passing through end face. Plane polarized with vibrate in plane of paper. Beam is allowed to passing through nickel prism. Nickel is rotating about incident beam as axis. Light varies and light is completely twice each rotation of nickel. Beam is plane polarized. Protection of circular polarized light. Circular polarized light is produced amplitude of O and E ray or equal there is phase difference of pi by 2 or path difference lambda by 4 between them. Parallel beam monochromatic plane polarized light is allowed for normal on a quarter wave plate such that the vibrate incident plane polarized light making an angle 45 degree with optical axis of plate. The circularly polarized light when observed rotation nickel show on vibrate according unpolarized light. Reviewed by rotation nickel, the circular polarized light remain according unpolarized light. If circularly polarized light passing through QWP, it is covered into plane polarized light. This plane polarized light can means rotating nickel twice rotation. On the other hand, according unpolarized light on passing through QWP remain according unpolarized light. Cannot by rotating nickel. Protection of elliptical polarized light. Monochromatic plane polarized light is allowed to fall normal on QWP such that the vibrate in polarized inside light make an angle with optical axis the plane. The plane polarized light on entering the QWP is lit up into O and E components have equal amplitude from QWP. There is phase difference of pi by 2 between the two components. They combine to form elliptical polarized light. Elliptical polarized light is using nickel. Light vibrate between maximum not zero minimum as nickel is rotating will be minimum when the principal plane is parallel to axis. Thank you to all.
Hello everyone. Today we are going to study about Lorentz offset polarimeter in optics and spectroscopy. First we know about the polarimeter. The polarimeter is a device that used for measuring the optical rotation that was built by optical active substances. The main diagram for this polarimeter, we put it into the slide. Here we have source that was entered into the lens. The lens we used in this experiment is convergent lens, that means convex lens. Then it was entered into the polarizer that produces the polarized light. The main equipment for this experiment is offset plate. The polarizer light is entered into the offset plate. Then the light move to the tube that contain the solution and is called optically active substances. And then analyzer, it is used for analyzing the polarized light. And analyzer is attached with the rotating scale. Then finally the light is entered into the telescope. There are the equipments are used in the Lorentz polarimeter. Let's see the offset explanation. It is most important device. It is made up of two semicircular plates. When joining the two plates, we have a sphere. The center line of the sphere is called optical path. In these two semicircle, one is glass and other one is quartz. Next, the clear image is formed by rotating the analyzer, and the measurement of rotating angle is measured by the scale above analyzer. Then the image is produced that was seen like a glass semicircle or quartz semicircle. These are illuminated separately. Similarly, in this semicircle, we have one half bright and one half dark. We can see only the bright half here. Sometimes we have both the half, so we can have illuminated for two components. Then see the specific polarity prism. S equal to theta by LC. This is the important equation for this experiment. Here the temperature is T and the wavelength denoted as lambda. From the above equation, the theta is the rotation that was held by the solution tube, and L denotes length of the solution using decimal units. C is the concentration of solution. We see how to do this experiment. The solution tube is first filled with water. So first we test the experiment using water. The reading is noted as RO R0. Then we rotate the analyzer. We have image that equally illuminated for bright. That reading denoted as R1. The difference between the experiment is written as R1 minus R2 equal to theta. We already discussed what is about theta. After we can measure specific rotatory power of water using offset polarimeter. Then we draw a graph between angle of rotation and concentration that produces slope value. When concentration increases, the angle of rotation also increases. Thank you for watching.